Now for the next part of this section, I want to talk about if we're trying to solve the quadratic equations with solutions that are not real numbers. So basically that means that you will end up with imaginary solutions. And when will that happen? When you have an equation of this form, x squared equals k, but this time your k is not a positive number, it's a negative number. When k is less than 0, that means that your solutions will be imaginary solutions. So we're looking at this example here. You have x squared equals negative 18. So you can see how this value is going to be different. Now when you apply your square root property, you end up with x equals square root of negative 18. You have to take the negative inside the radical because you take square roots of the whole thing. So you cannot leave the negative outside. You have to take the negative inside the radical. And of course you will end up with x equals negative square root of negative 18. Again, why do we have that? Let's look back at our square root property here. And your square root property said you have x equals square root of k or x equals negative square root of k. So that's what we have, the positive square root of k and the negative square root of k. This time the only difference is your k happens to be a negative number, and that's why you have that negative inside the radical. Okay, so now what we will do is rewrite these radicals. If you remember, we had said I equals square root of negative 1, right? That's the information we're going to use here. So for the negative part, we will go ahead and write that as I, so that once we write that as I, which is the square root of negative 1, this part disappears and becomes I, and all you're left with now is a positive square root of 18. And of course you can do the same thing on the other side. You have that minus, then this negative here will become I, and you are left with positive square root of 18. Okay? Alright, again 18 is not a perfect square, so you're going to have to simplify this radical. And you can write 18 as 9 times 2, 9 being the perfect square. And this time square root of 9 will come outside as 3. Don't forget that I. And since 2 is not a perfect square, it continues to stay inside the radical. Okay, let's see what happens on the other side. Again, we will rewrite 18 as 9 times 2. And you have the negative sign, of course. Square root of 9 will be 3. Then you have your number I, and square root of 2 will stay the same. Now you will notice again here, the way I'm writing this, your whole number goes in the front and your radical goes in the back of the I. So the whole number always in front of I and the square root of 2 always behind I, okay? If you have a negative symbol, again the negative will go right at the beginning of the number. So this is how we will simplify, and you can see whenever you have a negative k, your answers, your solutions will be imaginary numbers. So this time again we will say our solution set is 3i square root of 2 and negative 3i square root of 2. Okay? Okay, we'll look at one more example just so that we are sure of what we're doing here. Now this is one of those expressions which has a binomial as its squared term. So just like we did with the earlier examples, we'll follow the same trend here. You have 4m minus 7 quantity squared equals negative 27. You start out by applying the square root property, which will give you positive square root of negative 27, or 4m minus 7 will give you negative square root of negative 27. So again, the first thing you want to do is take that negative inside your radical and make that into an I term. So you end up with 4m minus 7 equals I square root of 27. So again, we take the square root of negative 1 outside as I, and you're left with a positive 27 inside the radical. Same thing on the other side. Don't forget your negative sign on the outside, and you'll end up with I square root of 27. Okay, let's go ahead and simplify our square root of 27, and then we'll come back and move the 4 and the 7 from the left hand side and get m by itself. So again, 27 is not a perfect square, so we need to simplify that, and you can write 27 as 9 times 3. And just like we did earlier, 9 will come outside of the radical as 3. Okay, your I, and then square root of 3 stays as it is. Let's go ahead and do that on the other side as well. 4m minus 7, and then your negative I will break our 27 down into 9 times 3, and that gives you 4m minus 7. Again, square root of 9 will come outside as 3. You're left with I, and square root of 3 will stay inside the radical, or stays the same. Now that we have simplified our radicals, we are ready to isolate our m. We're ready to get m by itself. We start by moving the 7 over. So we are left with 4m equals 7 plus 3i square root of 3. Again, you cannot combine the 7 with the other term because this term has an I and it also has a radical on it. So just leave this as 7 plus 3i over square root of 3. Now, to get m by itself, we divide both sides by 4, and you end up with m equals 7 plus 3i square root of 3 over 4. And that will be one of your answers. And we'll do the same thing on the other side. Again, start by moving your 7 over. Okay, so you are left with 4m equals 7 minus 3i square root of 3. Again, you cannot combine the two terms. Now get m by itself by dividing 4, and your second answer will be m equals 7 minus 3i square root of 3 over 4. Okay, so the only difference between a real number and an imaginary number is that you will see that the imaginary numbers have the number I in them, and of course that's what makes them different from real numbers. So your solution set is going to be 7 plus 3i square root of 3 over 4, and 7 minus 3i square root of 3 over 4. Okay, so basically this is what your section 11.1 is about, is trying to use the square root property to solve quadratic equations. And that is the end of section 11.1.